We will then talk about the ideas of speed and velocity. We use a symbol V for speed. It comes from velocity, but we'll be more explicit about what we do with velocity in a few minutes. Mathematically, anything typically that has a bar over it, no arrows, but just a bar, is an average or a mean. And this is simply a distance per time. So if you're talking about a trip, say, from here to Richmond, and you're doing 70 miles per hour, that's your average speed. There are times then that you would be much lower than 70. I would like to think pulling out of your driveway, you would probably not go from 0 to 70 instantaneously. When I use the word instantaneously, like I just did, that essentially means that my time interval goes to 0. And we'll talk about this as we develop into it. Often, we don't put a delta in front of the t when we're writing things down. Sometimes you'll see it, sometimes you won't, simply because trying to stop time is a bit tricky. So if we have a situation where a car travels 350 meters in 3.4 seconds, what is the average speed? Well, so the average speed is simply a change in x over a change in time. A change in x would be 350 meters over a time of 3.4 seconds. Now you can see why oftentimes we don't use a delta, because I did not phrase it as a change in time. One variation from the standard that you will often see me use is an abbreviation for SEC, for seconds, because frequently just using an S will look like a 5. So 350 divided by 3.4 I accidentally multiplied them and I knew that number was way too big. Okay, is 1.029 times 10 to the second meters per second. Let's look at significant digits. Well, this is 2 significant figures, or significant digits. This is also just 2. Okay, because a 0 not between non-zeros to the left of the decimal is not significant. Now that seems kind of arbitrary, but what this is telling you, because of the way this is written, is that you only know to somewhere between 345 through 354 meters what it is. You could only measure it to the nearest tenth of a meter. If it had been 350 point, then you are saying that you measured to within 1 meter. In other words, plus or minus a half meter, as opposed to plus or minus 5 meters. Okay, so that means we only have 2 significant figures, or significant digits, since we're dividing. So that means I have 1.03 times 10 to the second meters per second. Another advantage to using scientific notation is, in proper scientific notation, every digit is significant. Well, wait a minute. And if every digit is significant, then that's 3, which means, in fact, this is still not correct. So we need to drop it down. So in fact, it should be 1.0 times 10 to the second meters per second. This, okay, trailing zeros to the right of a decimal are significant. Now, I know that seems kind of arbitrary, but what this is saying is you know this precisely to the nearest tenth of a meter per second. Actually, it's plus or minus 5/100ths of a meter per second. Here, you're saying you don't know about this. This is only within 10 meters. This is within 1 meter. This, you can get it within a tenth of a meter. In other words, you were able to measure it within the nearest tenth of a meter. The idea of average velocity is simply going to be dependent upon where the initial and the final positions are with respect to time. And essentially all you're doing, and that's supposed to be a straight line, is you are finding the straight line between this and this. So that's a change in x over t, or xf minus xi over t. That's what that looks like. For an instantaneous velocity, it's a different situation. We're not talking about a straight line distance, but instead, and I say distance within respect to the graph, what we're looking at is the speed, the instantaneous speed, being the slope of a line that is tangent. And if you think about a trip to Richmond, you know that your speed is going to vary. And so if you actually were to look, where are you at this time? And then, oh, you had to back up and you had to go, and so on. So you're going to have something that varies. And so it's going to be, essentially, it's like looking down at your speedometer for an instant or a flash. Now, acceleration. For this class, we are going to be working with what we call UAM. Uniformly accelerated motion. Now, what that means is that your motions will all have a constant acceleration. Could be 0. Could be negative. Could be a fractional value. I should say less than 0 for negative. Could be a fractional value. Doesn't always have to be any particular thing. It's just going to be constant for us. Now, that implies that we will have our situation, if we were to plot velocity or speed versus time, this will be a constant. A is constant. Okay? So that's what that means graphically. So if you were to draw two speeds or two velocities over a given time, now we may have a situation where we have this and then we have a different situation where we have a V3. These two would be connected by a straight line. We'll have those possibly, but it's not going to be anything where it's going to be a constantly changing curve. So, since we said acceleration is a change in speed or change in velocity per time, and the acceleration due to gravity on or near the Earth's surface is a negative 9.81 meters per second squared, if a rock is dropped and falls for 2.50 seconds, what speed does it attain? Okay, if it's dropped, that means your initial speed is 0. I have had students who have gotten mad at me before because a problem will say something was dropped, and I wouldn't tell them in the middle of a test what the initial speed was. Okay, so we have a delta V, so that's a VF minus VI, and we have a time of 2.50. Now I'm going to go ahead and make one more substitution here. VF minus 0 over 2.50. All I need to do here is multiply. Now, 9.81 times 2.5 gives me, in this case, it's coming to negative 2.45 times 10 to the first. And this is meters per second. I'm actually going to change this to an expanded form because it's often that we do not write ten to the first. What speed does it attain? Now, speed has nothing to do with direction. Speed is simply how fast it's moving. The negative here and here are something we're going to talk about more as we get into it in the next little bit. That actually indicates a direction. So truly the speed is going to be positive. And so your final speed is 24.5 meters per second. 3 significant digits, 3 significant digits, 3 significant digits, or significant figures.